This podcast is called Circles and Their Graphs. We will be studying the different forms in which you can write the equation of the circle, and in particular we'll be looking at the utility of something called the standard form of a circle. Now we can write the equation of a circle using two different forms. Here in number 1 we are looking at what's called the general form of a circle. The general form of a circle is given by x squared plus y squared plus dx plus ey plus f equals 0. Notice you have an x squared term, a y squared term, an x to the 1 term, a y to the 1 term, and a constant term. Also notice that the coefficient of x squared is 1 and the coefficient of y squared is 1. Now if I were to multiply through every term by 3, then the coefficient of x squared would be 3 and the coefficient of y squared would be 3. But they would still be equal to each other, and that's very important. For that to be the equation of a circle, the coefficients of x squared and y squared must be the same. Now take a look at the more useful form of a circle called the standard form of a circle. The standard form of a circle is written as x minus h quantity squared. Now that's going to give me my x squared term. Plus y minus k quantity squared is equal to r squared. What makes this form so useful is that when you get it into this form, hk is the center of the circle and r is the radius of the circle, making it extremely easy to graph circles once you get them into this form. So let's try problem 1. Problem 1 says write the equation of the circle shown. So let's take a look at that circle. The standard form is x minus h. Now since I'm going to be substituting for that, I write it with an empty hole squared, plus y minus k squared equals r squared. So if I knew h, k, and r, I would be able to, and let's see, we're going to be subbing in there for r also, so let me put an empty hole there for r. So if we knew h, k, and r, we could complete the equation of the circle. Well, according to the standard form, the center is hk. So I come over here and try to identify the center of our circle, which is right here. And I notice that it is 4 high, so y is 4. I notice that it's 1, 2, 3 to the left, so x is negative 3. So the center is at negative 3, 4. 3 to the left, 4 up. The radius, didn't spell that very well, the radius is 4, and I can see that because from the center to the bottom of the circle is 4, from the center to the top of the circle is 4, from the center to the right of the circle is 4, etc. So the radius is 4, and we're ready to plug into our formula. Now remember, negative 3, 4, that's the same as hk, the center, which means h is negative 3, k is 4. So now I go back to my original form, x minus, and in the first empty hole I put h, which is negative 3, plus y minus. In the second empty hole I put k, which is 4, is equal to the third empty hole I put r, which is 4. And so for my final equation of the circle, I get x plus 3 squared plus y minus 4 squared is equal to 16. And that completes example 1. Fairly simple. From the graph we see the center, from the graph we see the radius. We plug in the center and the radius into the empty holes, and we immediately have our equation of a circle. Now the second problem says, and by the way, we could have done that backwards. If I was given that that was the original equation, then I could see that h was negative 3, k was 4, r squared was 16, so r would be 4. And so I could go from the final equation very easily to the graph. Plot 3, 4, give it a radius r, and graph it up. Okay, let's go